7C quadratic methods. So far we've learned 4 methods for solving quadratic equations. Solving by factoring involves setting it equal to 0, factoring using AC or difference of squares or some such method, and then you're going to set each factor equal to 0. Your square root property means that you're going to isolate the perfect square and then take the square root of both sides, solving for the variable after that. Completing the square is the whole procedure that we talked about before, and then quadratic formula we looked at last time. So when faced with a problem, how do you decide which method to use? First thing you want to do is look for the easiest way possible. So if it's already set up with a perfect square equal to some number, if it's in that form, you want to use the square root property. It's going to be the quickest, easiest method to solve. If it's not set up like that, then you want it in standard form. So you're going to get it all on one side equal to 0. Next easiest is probably the factoring, so check to see if it factors. If it does, solve by factoring. If it doesn't factor, look at your A term. See if there is a coefficient on your squared term. If there is, I would suggest that you just go ahead with the quadratic formula so you don't have to mess with a whole lot of fractions. If there's not, then you get to choose whether you want to use completing the square or quadratic formula. A lot of that's going to determine whether B is odd or even. If B is even, completing the square is probably just as easy as quadratic formula. So on the next side, you've got 4 problems here. And what I want you to do is stop the video and solve all 4 using the 4 different methods that you've learned. So I want you to use each method one time. To do this well, you need to stop and look at all of them and decide, okay, which one would be best for factoring, which one would be best for square root property, etc. So stop the video now and solve these problems. Your teacher will check these in class next time. Hopefully you got those. Other equations can be written in quadratic form and you can use the methods that we have to solve those. What you want to do is identify a variable expression and its square. To solve these, you use what we call a U substitution. The steps for that is to begin by looking for your perfect square. Okay, so you want an expression and its square. So what we're going to do is let U be the expression, the basic level of the expression. So we're going to rewrite the equation using the variable U, solve for U. And then realize that you were asked to solve for X, not just U. So at that point, you're going to substitute back in you're going to substitute these values back in to the equation for U and solve for X. So let's look at some examples. Each of these are paired where I'm going to go through one example and let you stop the video and do one that's very similar. So when you go to class next time, your teacher will make sure that you've done all of the ones that you were supposed to try. So here's our first situation. My basic variable expression here is x squared, because x squared squared is x to the 4th. So I'm going to let U equal x squared. If U is the same thing as x squared, then I can rewrite my equation as U squared minus 14U plus 45 equals 0. Doing this helps me solve this fairly easily. This factors nicely. And so I'm going to make this U minus 9 times U minus 5. Setting each factor equal to 0, I get U equal to 9 and U equal to 5. So now I know what the values are for U, but I was asked to solve for X. So I'm going to go back on this statement and replace U with x squared. So now I know that x squared is 9 and x squared is 5. So now this is really easy to use your square root property. Just take your square root of both sides. X is going to be positive or negative 3. Don't forget the plus minus when you take a square root. And in the second one, x is going to be positive or negative square root of 5. So my final solutions would be positive and negative 3, positive and negative square root of 5. Now stop the video and you go try number 6 on your own. Okay, hopefully you got that. Number 7 is a similar type of problem. you've got this expression x squared minus x, and then it's square. So I'm going to let u be x squared minus x, which means I can rewrite this as u squared minus 26u plus 120 equals 0. So now we're going to go factor this, and we get u minus 30 and u plus 4. Sorry, u minus 6 times u minus 20 equals 0. So setting each factor equal to 0, I would get that u equals 6 or u equals 20. But now I need to get what x is, so I'm going to take my u substitution and substitute back. X squared minus x equals 6, x squared minus x equals 20. Now I have two new quadratic equations to solve. So we're going to set this equal to 0. This factors nicely. So I get that x is 3 or x is negative 2. Same idea on the second part. X squared minus x minus 20 equals 0. So we get x minus 5 and x plus 4 for our factors. So x has to be 5 or x has to be negative 4. So my solution set includes negative 4, negative 2, 3, and 5. I have 4 different solutions for this equation. Now go try 8 on your own. Stop the video. When you finish with it, start the video again so we can move on. Okay, so number 9, we've got two options. In the last unit, we solved things that looked like this. We would isolate the square root of x, square both sides. We could also use a u substitution here. So what I'm going to do is model that. So I'm going to let u be the square root of x. Keep in mind that the square root of x squared is just x. So this would be u squared minus u minus 6. This again factors nicely. So we get u equals 3 or u equals negative 2. So now when we substitute back our u substitution, this means that the square root of x is 3 or the square root of x is negative 2. To solve those, I'm going to square both sides. This is going to give me x equal to 9. This one's going to give me x equal to 4. So let's go check these, because we know we need to check equations involving radicals. So I'm going to plug x equal to 9 back into the original equation, and I would have 9 minus the square root of 9 minus 6 equals 0. Well, the square root of 9 is 3, and so when I do this calculation, I get 9 minus 9 equals 0. And that works, so I know that this is a valid answer. Now let's check the 4. When I plug 4 in, I get 4 minus the square root of 4 minus 6 equals 0. So this would be 4 minus 2 minus 6 equals 0. Doing this calculation, this gives me 4 minus 2, which is 2, minus 6 is negative 4. This is not equal to 0. So 4 is an extraneous answer, and we need to remove it. In this case, our only answer would be 9. Stop the video and you try number 10 on your own. Okay, number 11 looks a little frightening because of the fractional exponents, but keep in mind we can use u substitutions here too. In this case, I'm going to let u be x to the 1/3 power. X to the 1/3 squared would be x to the 2/3. So what this becomes would be u squared minus 2u minus 24 equals 0. So now we can go factor, and I'm going to get u plus 4 times u minus 6, which means u is negative 4 or u is 6. Substituting back from our u substitution, This means x to the 1/3 is -4, or x to the 1/3 is 6. It may be easier to think of these in radical form, so remember that at 1/3 is a cube root. So what this problem means is that the cube root of x is -4. So to solve this, all we need to do is raise each side to the 3rd power. When I do that, I'm going to get x equals -64. Going through the same procedure with the other half, when I raise these to the power, I'm going to get x to be 216. That's 6 to the 3rd power. Now I want you to stop the video and go do number 12 on your own. Good, hopefully you have that, and we'll move on to number 13. Again, if you notice, this has the same format that the others have had, so we're going to let u be the square root of x minus 2. That changes our equation to 3u squared minus 7u plus 2 equals 0. Now you're going to go off and AC factor this. Remember, it's not just factors of 2, it's 3 times 2. So we're going to go through and do that, and we end up with the factors 3u minus 1, u minus 2 equals 0. Keep in mind, if 3u minus 1 is 0, 3u would be 1 and u would be 1/3. Same idea on this one. If u minus 2 is 0, then u would be 2. So now let's put u back in. We have the square root of x minus 2 equal to 1/3. Here, the square root of x minus 2 equals 2. So let's go through and solve these. Because they have radicals, I need to isolate the radical and square both sides. So the first thing I'm going to do is add 2 to move it across. So I'm thinking 2 plus 1/3. Okay? 2 would be 6/3 plus 1/3 makes this 7/3. So the square root of x would be 7/3. When I square both sides, then I'm going to get x to be 49/9. Let's go through the procedure over here. The numbers over here are a little bit easier. Adding 2 across, we're going to get 4. Square both sides, we're going to get x to be 16. And again, since there's a radical involved, we need to check our answers for extraneous solutions. So let's plug these back into the original equation, which I'm going to write over here for reference. Our original equation looks like this. So when I plug in my fraction, let's look at and see how that looks. Now we just have a little bit of messy arithmetic to do. So take your square root, and this is going to be 7/3 minus 2. Again, 7/3 minus 2. So we're going to go off and calculate what 7/3 minus 2 would be. 2 would be 6/3, so 7/3 minus 6/3 would just be 1/3. And now we need to square that. So this becomes 3 times 1/9 minus 7/3 plus 2. So 3 times 1/9 is 1/3. 1/3 minus 7/3 is a negative 6/3. Negative 6/3 is negative 2. And negative 2 plus 2 is 0, so that does work. I'm going to leave you to check the other answer on your own. The arithmetic's a little bit nicer. So you're going to go through and check x equals 16 and make sure that it works. The video is going to stop here, and we will finish the last page of notes in class next time. Make sure that all of your problems are that were left for you to try are complete all the way through number 13.